Greetings. Welcome to a video on Build a Bigger Field. So, in office hour tonight, I intended to go over this and show everybody how to work it. And then I discovered that we had some problems. Houston, we got a problem. So I decided I'd just go ahead and do it as a separate video and work through this with you and show you where you may have made a mistake when you were working it and how to go and fix that mistake if you did do that and come back and perhaps clean up things a bit for us. Okay, so I'm going to go through each of the slides here and then we'll go back and look at the actual discussion questions. So which of these three rectangles has a largest perimeter? Let's just guess it was B and go here and go, well, fun fact, they all have the same perimeter. And to calculate the perimeter of a rectangle, let's go remind ourselves how to do that real quick. To calculate the perimeter of a rectangle, what you do is you say, well, P is equal to twice the length plus twice the width, okay? So what we notice here is on the first rectangle A, it's 4 by 21, so that's equal to 2 times 21 plus 2 times 4 if we stay with traditional length and width. Well, actually it was the other way around, but it does not matter because it's all commutative. So this is going to be what? So 21, and I double that, that's going to give me 42 plus 8. The punchline is that comes out to be equal to 50, okay? So 50 meters is what you get for that perimeter. All right, so that's going to be the same here. You get 20 plus 30, which is 50. You get 40 plus 10, which again is 50. So all three of these rectangles have a perimeter of 50, all right? Now, what they want you to do is build a rectangle with a perimeter of 50 meters of fencing. And at first I thought this is where the mistake was, and then I realized they won't let you make a mistake. You have to keep moving it around until you get it to 50. And when you get it to 50, there they go, bink. Oh, this is okay, you can build that field. All right, so that one was sold, that one 50. And they want us to make a different one. And again, when it's at 50, it'll let me call it a field. We'll call that field B. And now field C, they say make it as big an area as possible. And we'll say, I'll say right there is field C, okay? All right, cool beans. Now, this is where the wheels fell off it. You have to calculate the area of your fields, okay? And somehow the arithmetic here escaped you. Now, if you go back and you take a look at the discussion question, okay? Excuse me, the initial part of the discussion question here. Let me go back to here. Let's give ourselves a little more real estate, okay? And we go to the Desmos tab. Come on, you. There we go. Thank you. Finally goes there. All right. It says, read the following instructions carefully before you attempt the activity. And down here it says, oh, well, if they gave you the perimeter was 50 and they gave you the length was equal to 15, how do I find the width, okay? And it shows the instructions on how to do that, all right? So let's go through that with some live ammo with the actual numbers that we've got here, okay? So in rectangle A, my length here is 18, all right? So my length is 18, and in every one of these cases my perimeter is 50, then P equal to 2L plus 2W, with L again equal to 18, that's going to say, okay, 50 is equal to 2 times 18 plus 2 times W. Well, let's go do the arithmetic here. So let's see, what does that say? That says that I'm going to take 50 and subtract from that 2 times 18. Which gets me back 14. Let's divide that by 2. And we get back 7. In other words, if I solve this equation right here, I get 7 is equal to W. So back at the Desmos activity, what that means is the width here is equal to 7. Whew, all right, we got that. Now, what about the area? Well, the area of a rectangle is equal to its length times its width. Well, in this particular rectangle, the length was equal to 18, and the width is equal to 7. So going to my calculator here, I'm going to go 18 times 7, and that's going to get me back 126. So let's go back and put that into the table right here. I'm going to put in 126. All right, let's go take a look at rectangle B. So the length was 11. Okay, so let's go ahead and get a fresh piece of paper here. So again, the perimeter is equal to 50. The length is equal to 11. So that says that 50 is equal to 2 times 11 minus 2 times W, which says that 50 is equal to 22 minus 2W. All right, so subtract plus, not minus. What the heck am I going to go minus there? I'm getting ahead of myself. I'm already thinking about subtracting the 22. Sorry about that. So come over here, get my calculator, and I'm going to take the 50, subtract the 22 from it, and I get back 28, and let's divide that by 2, and I end back with 14. Okay, so I get 14 is equal to my width. All right, so let's go back and put that in the table here. So that's 14, and now I need to know what my area is. Well, my area is going to be 11 times 14. So 11 times 14, and that gets me back 154. Okay, cool. All right, one last one. I got a 13 there for the length. So let's go see if we can figure out the width when the length is equal to 13. So the perimeter again, equal to 50. The length is equal to 13. So you've got a 13 right here for the length. Okay, so that says that 50 is equal to 2 times 13 plus 2W. Okay. All right, so that says that 50 is equal to 26 plus 2W. So if I take 50 here and I subtract from that 26, I get back 24. We'll divide that by 2, and we get back 12. Okay, so get back 12 is equal to W. All right. So what that says, going back to our table here, it says this is 12, and that says that my area in square meters, well, that's going to be 13 times 12, isn't it, right? Which is 156. All right, so that's 156. Cool. Okay. So got my areas and my lengths and my widths all input there, and now let's go to the next slide here. It says, imagine looking at your classmates' fields. Now imagine we made a graph of the area of those fields against their length. What do you think the graph would look like, and describe it? Okay, so let's think about this logically. If the length is 0, then the area of the field is going to be 0, all right? So we know we're going to start down here in the origin. And then as I make the length bigger and bigger and bigger and bigger, the area is going to go up. But at a certain point, what's going to happen is I'm taking up so much of the total perimeter with the length. Now the width is getting smaller, and the width is getting smaller to the point where, again, I'll come back down to 0 because I'm going to have a 0 width at a particular length. In other words, if I use all 50 meters, or that right there is 50. If I use all 50 meters, I'll do it up here. If I use all 50 meters to make just the length, there'll be nothing left for the width, right? Okay, so it should look like a parabola. So that's what I'm thinking, is that we should get a parabola. I'm not seeing a parabola in that data. Okay, now if you look at my 3 orange dots here, you can see they're all starting to fall, kind of like on the parabola that I drew back here on the previous slide. So I'm suspecting that, yes, this should have looked parabolic, but somehow we messed up on the arithmetic. So what you need to do, there's a few of you, see you folks right in here, you got it right, okay, like those look like they're right, okay, I got some folks that got it correct here. If you kind of look through there, you can see some points that land on the parabola. But you folks up here, or over here, or over here, or down in here, you didn't do the arithmetic correctly back in the table. So you need to go back into the Desmos activity, and you need to fix this table. In other words, you need to go and do this arithmetic correctly here. Now what I've done is I've left it open until Sunday, so you need to get back in. I'm not going to award I'm going to give you 0 points basically if you don't do that table right. You got to go back and fix that. All right. So I'm going to hold you hostage over that table until you get it in there correctly. All right. If you do it correctly, when you come here to this screen, you'll see your 3 orange dots are going to line up nicely on the parabolic curve. Okay. So the answer here is what family function best describes it, and it should have been quadratic, and it looks like a downward opening parabola. Okay. All right. So we look at some of these other people that said it was quadratic. They kind of are seeing the arch, but then there's some people that just were not getting the right data in there. Okay. All right. So you said quadratic function best describes the data. Drag the green point so that it represents the graph you find the largest field. Well, that's going to be roughly right about there-ish. It turns out to be at about 12.5. Okay. At 12.5 is where the biggest field is at. So let's see, that's 10, 11, 12. Let's see that. Yeah, roughly in that neighborhood over somewhere around in here. Okay. I'll let you make that pretty, but it's somewhere in that neighborhood. Okay. All right, now any old field. So what is the area of any old field, one with 50 meters of perimeter and length x? Show your answer in the table. So they want you to give box D here. All right, so how do you do that? All right, well, let's go back over to the whiteboard for a moment, and let's go ahead and see if we can figure that out, okay? So we have 2 formulas. We've got the formula the perimeter is equal to twice the length plus twice the width, and we've got the area is equal to the length times the width. And the question they're asking here is how can you find the area of any old field with a perimeter of 50 meters and length of x? Show your work in the table, okay? So they're saying is this distance right here is x, and they want to know what is the area as a function of x. That's really what they're asking you for. So here's the deal. We're going to come over here, we're going to take our 2L plus 2W, and we're going to put in what we know over here from the picture. We know that P is equal to 50, okay? And we know that the length is equal to x. So what that tells me is that 50 is equal to 2 times x plus 2w. So in other words, I just substituted in the x in for the w, all right? All right, cool beans. Okay, so let's go ahead and let's solve, just like we did in the previous table, let's solve this for w. So in other words, when we went back here, on each of these arithmetic steps, what you did is you solved for w in every one of those. So let's do that again, but this time we're going to do it for any old rectangle. And so that means I'm going to go ahead and subtract 2x from both sides. So that's 50 minus 2x is equal to 2w. And then I'm going to go through and divide both sides through by 2. And if I do that, I get 50 over 2 minus 2x over 2 is equal to w, which tells me that 25 minus x is equal to w. All right, so now I want a of x. In other words, I want a function of x. Well, notice that L is now being played by who? Well, that's x, isn't it, right? And w, that's being played by who? 25 minus x. So that tells me that a of x is going to be equal to what? Well, it's x times w, which is 25 minus x. All right, so let's go back to the table now. So they say, what is the width? Well, the width is 25 minus x, right? And what is the area going to be? Well, the area is going to be x times 25 minus x. Okay, feeling good. Okay. Oh, look. Oh, you see that funk? Oh my God, look at so everybody who fell on the drive, your dots fall on that parabola, then by gum, you did it right. If your dots do not fall in that parabola, then you need to go fix that table, okay? All right, so what does this tell us about the dimensions of the field with the most area, okay? The greatest area will occur at the vertex. In other words, at the maximum point. Okay, so that's the first one. So what is the area of this field? Okay, so let's go see if we can figure that out. So if we want to find out the maximum area of our field here, let's make a second one in case I want to come back to this sheet here. So I'll make myself a new piece of paper just in case I need it. All right, so what do we come up with? Well, we've got a of x is equal to, well, what was it again? Oh, sorry, I want to go to a different piece of paper. It was x times 25 minus x, right? All right, let's go ahead and simplify that expression by distributing the x, and that's 25x minus x squared. In other words, I take the x, give a copy there, take the x, give a copy there, right? Okay, or this is equal to minus x squared plus 25x, putting it in standard form, all right? Okay, so what do we want to know? We want to know the vertex of this parabola. Well, the vertex is at the ordered pair hk. And so the vertex of this parabola is found by finding the maximum value of x. Now you can also do this on the calculator. There is a kind of a cool tool in the calculator that you can do this graphically. So I'll show you that first and then I'll show you the algebraic, all right? So if I go into my y equals, clear out any craziness I had going on in there, and I'm going to put in negative x squared plus 25x. All right, so we saw by looking at our previous work that we can go from what, 0 to, I mean, the maximum is 50. If you put everything into the length, you could go out to 50, and that's as big as you're going to get, okay? Now what about the height? Well, can't have negative area, so remember the y-axis is representing area, so we'll go with a 0, and then the maximum, I think 200 square meters would be more than enough. I think that's going to cover it. All right, so if a graph was Shazam, we get a graph looks something like that, okay? So actually the 50 was a bit big. Let's make that smaller. Let's go 25. Oh yeah, it's 25 because I can't use, it's not 50, it's 25. Sorry about that because I have to have another side. So yes, 50 total, 25 and 25. So that point that I drew earlier on the graph was incorrect. That shouldn't have been 50, that should have been 25. Anyway, that point right there is going to be the maximum point right there. So I'm going to go second calc. I'm going to go number 4 for maximum. And the maximum finder wants you to take your little Frogger guy, put him to the left of the maximum, hit an enter. Take your little Frogger guy, take him to the right of the maximum guy and hit an enter. And then put it to the center and hit an enter. And it tells us at about roughly 12.5 meters. Notice there's a bit of round off error. This particular routine on the calculator is sensitive to that initial guess. The closer you get to the actual value, the better it's going to get, all right? So based upon the calculator, it looks like the vertex, the h value, is equal to 12.5, and the k value, which is the maximum area, that's equal to 156.25. All right, we can also do it by hand because it turns out there's some nice formulas. H is equal to minus b over 2a. So that would be negative 25 over 2 times negative 1, which gets me, look at that, 12.5, right? When you simplify that. Okay, now how do I get the 156.25? Well, that's the k value. And what I do is I come in and I evaluate a, my function, at 12.5, which says that's going to be negative 12.5, that's a point right there, quantity squared, plus 25 times 12.5. I'll let you do the arithmetic on there, but you'll, oh, well, what the heck, I'll go ahead and do it here. That's going to be what? So negative parentheses 12 point, oh, let's get out of here. Negative 12.5 squared plus 25 times 12.5, and we get back 156.25. Woohoo! So we get 156.25. Okay. All right, let's go back to the Desmos activity. So you guys need to do that yourself also. That's a really valuable thing. So to answer part 2, what is the area of this field? It is 156.25, okay? All right, so let's say you didn't have 50 meters, instead you had 60 meters or 600 meters or m meters. Write the equation for the dimensions of the biggest field given any length of fencing. Use the sketch tool to help illustrate your thinking. Okay, so let's go back over to the whiteboard here. Let's make one more whiteboard piece. Okay, so there's a new whiteboard. All right, now this time they say, what if the perimeter was equal to m? All right, so in other words, let P be equal to m. So that says that m is equal to 2L plus 2W. And we also still know that what? That the area, sorry about that the area is still going to be equal to the length times the width, all right? So back to the question real quick. It says, write the instructions of how to find the dimensions of the biggest field given any length of fencing. Okay, so they want it as a function of the length. In other words, I need to get the W out of here. So what that means is that M minus 2L is equal to 2W. Divide both sides through by 2. And we get M minus 2L over 2 is equal to W. So what I'm going to do is I'm going to come in and I'm going to say, okay, that's a W, that's a W, and that's a W. So what Desmos wants us to give back is they want to give us a function of L, the area, excuse me, as a function of the length, which says that's going to be the length times M minus 2L over 2. So it looks very similar to the function we just plotted a minute ago with a fixed length of 50, where that would be the 50 right there, and the L would be played by X, okay? So they just a little bit of variable substitution on this, but it's basically the same idea, all right? So that's number 10. And then number 11, imagine you have 50 meters of fencing again, but this time you're building along a wall, and you need only to fence 3 sides of your field. Click and drag the corner of the fence and make the biggest fence. Write down the dimensions and how you figured it out. Okay, so this time notice they're not going to let you get away with using more than, you have to use 50 meters, right, of fencing. And so the problem is you can, excuse me, they're going to let you get away with doing anything. I mean, I could do this, and that's way more than 50 meters of fencing, obviously, okay? So you have to draw to make the biggest field based upon some sort of knowledge of what those should be. Okay, so let's go do that. So let's go ahead and get a fresh screen here. All right, so you have your fencing this time. You only need 3 of them, because what you're doing is you're building up against the side of a building here. So what that means is that you're going to have, let's use X's and Y's just to make our life easier here. That's going to be an X, that's going to be an X, and that's going to be a Y. So notice a new game. That's no longer got the perimeter of 2L plus 2W. This time the perimeter is 2X plus Y. Notice I got an X, I got another X, and I got a Y. The area formula, though, that's going to be the same. The area is going to be X times Y. Okay, so let's come back over here and notice that what they said is, again, you've got 50 meters, all right? So I'm going to come in here and say, okay, 50 is equal to 2x plus y. And again, I want it as a function of x, of just one variable. So let's go ahead and subtract 2x from both sides, and we get 50 minus 2x is equal to y. So that says a, or a of x this time, is equal to x times 50 minus 2x. Well, if I distribute that x there, that gets me 50x minus 2x squared, which says that's minus 2x squared plus 50x, right? Okay, so what they want to do is they want us to come up with the dimensions that make the biggest field, all right? So to do that, we need to go find the vertex of this parabola. Because if we think about it again, go back to the sketch earlier, is that now what we've got is we've got this parabola, looks like this, where this is x, which is your length. And then this, the vertical axis, is the area. Notice this is a downward opening parabola. So if I find that point right there, I'm going to find the length that gives us the biggest or the maximum area. So I'm going to do this one using the vertex formulas, all right? So if I use the vertex formulas on here, h is equal to minus b over 2a, which says that's equal to minus 50 over 2 times negative 2, right? See, minus b over the 2a. There's my a, there's my b. Okay, or you, if you want to, put it in the calculator, and you can do it that way. You can totally use that maximum finder that I just showed a minute ago. So let's see, what's this going to be equal to? Well, this is negative 50 divided by 4. Negative 4, excuse me. Well, what does that give us? Let's look on the calculator. I believe that's 12.5 again, right? Sure is. Okay, so it comes back equal to 12.5. All right, so that point right there is 12.5. All right, cool. So what they want to know from us, let's go back to the thing here. It says write down the dimensions. What are the dimensions here? Well, the length is 12.5 meters, just like before. But notice, let's go back to the thing here, that that's not 12.5 is not going to be equal to our y this time. In other words, we're not going to get a square here like we did in the previous one. So I need to come back to this formula right here to figure out, or better yet, this one, to figure out what the y value is. In other words, I want to know what this length is right here. I know this one is equal to 12.5. So that's 12.5. That's 12.5. And now this is the one I need to find. So I'm going to plug my 12.5 into this formula, and it'll tell me what my y is. So I get 50 minus 2 times 12.5, and that's going to be equal to the y. Oh, let's go back here again. I actually want to be on u, and then I want to be on u. There we go. Okay. So I'm going to get 50 minus, what, 25? Oh, look at that. It's going to come out to be 25, isn't it? So the y value is equal to 25. So I'm going to use 12.5 meters, 12.5 meters, and 25 meters. That's going to come out to be equal to 50 meters in total, all right? You could have done that without all that rigmarole if you wanted to. All right, so the length is, actually, that doesn't make any sense. We're going to make the length 25 meters and the width 12.5 meters. So that's 25 meters and the width. Sorry about that. But when I think about the dimensions, that makes more sense in terms of the way we standardly write down width and length. And that is 12.5 meters. And if you want to come over here, you can actually drag things around until you get it to what it's supposed to be. So let's see. So that would be 12.5 by 25. Let's see if we can get it to go exact. Oh, there we go. Okay, so that is the largest rectangle you can make with that fencing where you make a river or a building on one side, okay? Alrighty then, so if any of that doesn't make sense or you want to look at it in print, I have most of that written up already right here, okay? In the prelude to this problem here, the part that it said, read the following instructions carefully before attempting the activity, okay? All right, so the three discussion questions are basically the three questions from the slides that you just basically have to come back and re-report them into your discussion question. So feel free to edit your responses to the discussion question also now that you've watched this video. Thanks for your attention. Sorry that was a little chunky, but I'm doing this at 10 o'clock on Thursday night. So if I made any mistakes, you let me know because God knows it's likely.